Hi, in this lecture we will learn quicksort algorithm. In order to understand quicksort algorithm, let's look these three different arrays. Our first array contains these values. And the second array contains and the third array contains. This is the first array, second array, and the third array. When we look to the first array, which element is in its correct position? 20 is located at the right position because 20 is the smallest element in this array and it is located at the beginning of the array. In the second array, which element is positioned at the correct position? In the second array, 100 is located at the right position because 100 is the largest element in the array and it's located at the end of the array. And in the third array, 60 is located in the right position because the values located at the right side of 60 is larger than 60 and the values is located at the left side of the 60, they are all smaller than 60. So 60 is the middle element in the array. Now we can apply quicksort algorithm to the array that I am going to write now. In this array, let's sort one element at a time. And at first, we need to select a value as a pivot value. So we select the first element, 60, as a pivot. Now we have to find the location of 60 on this array. The values which is larger than 60 should be located at the right of the 60 and the values smaller than 60 should be located at the left side of the 60. In order to find these values, we have two variables. And these variables will be A and B. These variables, for example, A will find the values larger than 60 and the B will be used to find the values smaller than 60. And in order to understand that A became invalid for this array, we have to add a very big number to the end of the array. And at first, B will point the maximum element in this array, which is infinity. Now, let's begin our algorithm. First, we will increment A by 1, and A comes here. And now, A shows 80, and 80 is larger than 60. If the value of A is larger than 60, we stop. Then we decrement B by 1 and now B points the last element which is 40. And B 40 is smaller than 60, so we stop again like we did in the A. And now our array looks like this. Now A points 80 and B points 40. We found an element 80 larger than 60 and we found an element 40 which is smaller than 60. Now we will swap these values. 80 and 40 will be swapped. After swapping these values, our array will become like this. Now again we increment A by 1. Now A shows 70 and the value of A 70 which is larger than 60, so we stop and we decrement B by 1 and B shows 30 and 30 is smaller than 60, so we stop for B again and now we will swap the values of A and B. 70 and 30 will be swapped again. And after this swap operation, our array becomes like this. And again, we increment A by 1. A now shows 100 and the value of A 100 is larger than 60, so we stop and we decrement b by 1, and now b shows 20, and 20 is smaller than 60, so we stop for b again and we change the values of a and b. And this time we increment a by 1. A now shows 50, and this time 50, the value of a, is not larger than our pivot value. 50 is smaller than 60, so we do not stop. We increment a by 1 again. And now a shows 90. And 90 is larger than 60, so we stop and we decrement b by 1. And now b points 90, like a. And 90 is not larger than 60, so we decrement b by 1 again. And now b points 50. And 50, the value of b, is smaller than 60, so we stop. And as you can see, b is now at the left side of a. It means that we traced our array completely. And on this point, we exchange or we swap the values of b with our pivot value 60. 50 comes here and 60 comes here. And now we can say that 60 is sorted, and we found a position for 60 in the array. And for this array, we can say that the values located at the left side of the b is smaller than 60, and the values located at the right side of 60 is larger than 60. And we call the position of 60 as partition point. And next, we do the same process for the values located at the left side of 60, and the same process for the values located at the right side of 60. And this process can be made by recursive calls. And in order to make quicksort, we have to have minimum 2 numbers in our array. Also, we have to include the infinity to the left values. For this point, infinity will be used as a reference for these values, and 60 will be used as a reference for these values. 60 will act as the largest element for these values. And all steps that we did to find the position of 60 is called partitioning process. Now we can write our codes to implement quicksort algorithm. In order to implement quicksort, we have to find a partition point of our array. Also, we will select the first element as pivot. So pivot value will be the first element in our array. And low will represent the first index. Also high will represent the last index. Also, we need 2 variables, a and b. A will be used to find values larger than pivot value, and the b will be used to find values smaller than our pivot value. Or we can say that we can increment a if we find an element smaller than pivot value. Also, we can decrement b if we find a larger element than pivot value. So we will use do while for this algorithm. We will increment a by 1, or while d of a, the value of our array, is small and equal to our pivot value. Also, we will do the same logic for the b. We will decrement b by 1 while the value of b is larger than pivot value. If you remember, we incremented our variable a by 1 and we stop if we find an element which is larger than our pivot value. If you remember, when we find an element which is larger than 60, we stopped for a. Also, when we find an element which is larger than our pivot value, we stopped for b. But we incremented a by 1 when we find an element which is smaller than our pivot value. For example, when we find 30 here, 30 is smaller than 60, so incremented a by 1. Also, we did the same for b. So in our codes, these while loops, if the value of d is smaller than pivot value, we increment a by 1. Also, we decrement b by 1. By doing this, we are tracing our array. And we have to do this procedure in the third do while loop. A is smaller than b. Also, at first, in the beginning, we have to assign the values of a and b as a should be assigned as low and b should be assigned as high. When we finish the third do while loop, it means that now b is located at the left side of a. Then we can swap the values of b and pivot value. If you remember, at the last example, if you remember, b was pointing 50 and b located at the left side of a, swap the values of b and pivot value. So this time we will do the same. We will swap the values of pivot with the values of b, and we will return the value of b as a partitioning point. This function will return the partitioning point. Also, we need to create another function, and this function will be our Quicksort function. And in this function, we need to have two elements, minimum two elements in an array. So we have to check if low is smaller than high. So it means that we have at least two elements in our array. Also, we will find our partitioning point by sending our array and low and high. This function will be named as partition point. So we will call this function to find the partitioning point, and it will return a partitioning point. And let's call the partitioning point as p. Also, we need to call Quicksort function again as recursive calls to find the right positions of other values. So I will call the function again, the name of our array, low, the low index, and the p, the partitioning point. This point, we are trying to sort the left side of our pivot value. This example, we are partitioning this point. We are quicksorting this part. We are using b, our pivot value, as the largest element. Also, we have to call quicksort again for the right side of our partitioning point. And this time we will start from p plus 1. We will start from this position, b minus 1, to the last index. Okay, let's write our codes in Xcode and see our results. At first, we have to define a function that will return the partitioning point of our array. And it will return an integer value, and it will take an array as a parameter and the lowest index and the highest index of our array. At first, we will select the first element of our array as pivot. Also, we need two variables, a and b, and a will take the value of low, b will take the value of high. So at first, a will point the first index of our array, and b will point the last index of our array. And we will increment a by 1 if the value of our array is smaller than pivot value. Also, we will do the same for b. We will decrement b by 1 if the value of our array is larger than our pivot value. And we will repeat this process while a is smaller than b. At the end of our do while loop, it means that the value of a is larger than b. Then we have to swap pivot value with the value that is pointed by b. And we will return the value of b as partitioning point. Also, we have to define a swap function. And now we can implement our quicksort function. The parameters are the same. And we will check if low is less than high. And first we have to find a partitioning point. P equals to partition point D, low and high. After we find the partitioning point, we can call the quicksort function again. It will start from low up to P. Also, we have to make a quicksort for the right side of our pivot value. Now we can implement our main function. And for infinity, we have to declare int 32 max for the largest element in our array. And we will call quicksort. Low will be 0 and the high will be the length of our d minus 1. So if our array contains 11 elements, our high should be m minus 1. And after we sort our array, we can use a for loop to print our sorted array elements. Now our function should work, and okay, we have to add namespace std. Okay, no errors. Let's run our program. Okay, our program is not working correctly. I think we have to change int 32 as int max. Also, let's check our functions. Partition point function first. We are incrementing a by 1 when d of a is less than pivot. Okay. Also, we are decrementing b by 1. d of a is larger than pivot. Okay, we need to change this as d of b. Then inside these do while loops, we have to make a swap. If a is larger than, if a is, we have to swap the values of a and b. Now let's run our program. Okay, this time our array is sorted 4, 8, 10, 20, 21 and 78. Okay, our program works fine. Okay, this is the end of our lecture. I hope you liked the video. See you next time.